So you should have already completed your lab. Now I'm going to give you a little bit of instruction on these charging methods. There are 3 different types of charging methods, and if you came up with more, I think what you might have done is lumped some of the same ones into, you just made, for instance, charging by friction, 2 different ones. But we're going to go through each one of these step by step. Some of them are less complicated than others. So we'll start with the least complicated of all, which is probably the most commonly, and you probably have probably known this anyways. And we'll give you some real life examples of charging by friction for sure once I talk about it. But charging by friction is a charging method for 2 neutral objects when they are rubbed. And so basically what you're going to do is you're going to take 2 neutral objects and you rub them together. You should have observed this with John Travolta. When he rubbed his foot against the carpet, he became negatively charged and the carpet became positively charged. And so those 2 neutral objects, when rubbed together, created 2 charges. And what literally happened was John Travolta literally scraped electrons off the ground and donated it to his body, making him negatively charged. And so that's called charging by friction. And so one substance will become negatively charged while the other becomes positively charged. The question is, which one becomes positive and which one becomes negative? Well, that's a really good question, Mr. Doherty. Why don't you tell me? Well, I'm glad to tell you. The way that they have determined what becomes positive and negatively charged, basically what they did is scientists basically rubbed a whole bunch of objects together, noted what their charge was, and then created a list called the Triboelectric Series. And so basically what the Triboelectric Series is, and you don't really have to remember the name, I'm going to provide you with information whenever I need you to know it. The Triboelectric Series looks like something over here on the right, where it lists things from positive all the way down to a negative charge. And so basically it lists all these different objects, like cat fur is, when rubbed together with silk, will become positively charged. But cat fur when rubbed with nylon will become negatively charged. So for instance, which one will become negatively charged, silicone or dry skin? Well, silicone, where is silicone? Silicone, I believe, is down here. Silicone rubber right down there at the bottom. And dry skin is somewhere on here. Oh, right there. It's positive. And so the dry skin would become positive because it's higher on the Triboelectric Series. It's that simple. The second method, before I move on to charging by conduction, charging by friction, you probably are very familiar. This is traditionally what we think of when we think of static electricity buildup. When we rub a balloon against our hair, when you have the dryer going, maybe you didn't put in a dryer sheet and your socks are like sticking to all your other clothes, that's because they become charged by friction due to the rubbing of 2 neutral objects. Okay, so the second method of charging an object is the charging by conduction. And conduction creates likely charged objects by simply touching an object. And when I say likely charged objects, I think you'll see what I mean here in just a second, but an object can very easily lose its charge by charging by conduction. In order for this to happen, some basic things have to be there. First off, one object has to be charged. You can't touch 2 neutral objects together and expect charge to be transferred. There has to be one object that is charged. And the difference between contact and charging by friction is this is no rubbing. It's just literally just touching it. And so when I say in contact, there is no rubbing going on. And so I have these particle diagrams. And if you remember, this is Thomson's model of the atom. This guy right here, because it has 3 electrons in it, we're going to say that's neutral. But this guy over here, because it has 5 electrons in it, we're going to say that is negatively charged. And what we're going to say is, let's say we want to create, we want this neutral object to become charged. And so what I would do is, I would literally just bring this guy right up to it to where it touches, just like that. And so when I touch it, what's going to happen to this neutral object? Well, the charges are going to be distributed. And so what's going to happen is this guy is literally going to get transferred to this guy. And then all I have to do is separate this guy. And then I've got one object that's negative, but then over here I also have created a negative charge. Just like that. And so just simply by touching. Well, how would that work for something that's positively charged? Well, here I've got a positive charge here, and here I've got a neutral charge. And so let's say I bring this neutrally charged object close to this positively charged, and so much so that I actually physically touch it. Well, what's going to happen here? Well, this electron right here is going to get transferred over here. Well, this guy is still positive. But then when I separate it, this guy is still positive too. And so this is called charging by conduction. There's no rubbing, because with rubbing and charging by friction, you start with two neutral objects. Here you're creating two charged objects from just one charged object. So the final method is the most complicated of them all. It's called charging by induction rather than conduction. And basically what you do is you create oppositely charged objects through polarization and grounding. And with your simulation, you had to use the ground to be able to accomplish this. But first off, an object is brought close to the charged object. The difference between charging by conduction and induction is conduction, you physically touch them. Induction, you do not physically touch them. You just bring it close. So you bring this neutral object close to this charged object. Then the neutral object is then grounded, and then electrons are either removed or to the ground or donated from the ground. And so let me give you some examples here. So we'll get into the definition of polarization. I'll kind of show you that here in just a second. But we've got this neutral object, and then we've got this positive object. And so what we want to do is we want to bring this guy right here close to it, but it's not going to touch it. So now let's think about, on an atomic scale, what's going to happen in that neutral atom. Well, this electron right here is feeling an attraction because this guy is positively charged. And so this individual electron is going to be attracted, therefore pulled really close on here. And this guy is also going to get really close because it's feeling that positive charge. And this guy is too. In fact, all the electrons are going to rush to this side. That's what this process is called, polarization, where basically I have created two sides here, one with a negative charge and one with a positive charge. And so polarization, I basically just separated the charge within a neutral atom. Okay? Well, then what I'm going to do is I'm going to grab my ground source over here, which notice it has a whole bunch of electrons just in it, right? And I'm going to touch the ground to the neutral object. When I touch it, well, what's going to happen? Well, these electrons in the ground are going to feel the attraction here. And so it's going to get pulled up, ooh, pulled up, just like that. Then when I remove the ground, if I can, yeah, it may not be the best. And then when I remove the ground and then I take this guy away, well then this guy has these electrons have no desire to be in the middle anymore, and they just want to be spread out. And so now I've created a negatively charged object from a positively charged object. Let's do the reverse real quick. So now I've got a negatively charged object. I bring this neutral object close, and then, oh, forgot the polarization process. Because this is negative, these electrons are not happy. They're on, oh, why does it always do that? These want to get away, and so they're running away to this side, and then I've got my polarization right here, separation of charge, to where this side is negative and this side is positive. Then what I'm going to do is I'm going to bring the ground in, but notice that the atom is still neutral because it still has a total of 3 electrons in there. I touch it, and these guys don't want to be anywhere near this atom, and so what they're going to do is they're going to rush into the ground source this time, and of course they're just going to disappear because I don't know why they have to go behind that thing. Anyways, they disappear. Then I remove my ground. Let me just delete it. Electrons are outside now. And then when I separate these guys out, this guy is able to freely flow wherever, so then I've created a positively charged object from a negatively charged object. These are the different charging methods, and I think that, yeah, these are the different charging methods, and you should be able to use these in these particle diagrams to help you with your next task.